Hello everyone. In this video, we will try to solve the problem on related rate. And in order to solve this related rate problem, we have to take certain steps. So let me just show you the first step. So what we can do is, so here is the first step we will be taking. We will read the problem carefully, and then we will label the or draw the picture if we need to. So this is a question about a spherical balloon. It is inflated and its radius is increasing, and what is happening that we have to find the rate at which the volume of the balloon is increasing. Okay, so we read the problem. So of course the problem is about sphere, so we will draw a sphere in the two-dimensional space. It's not an easy thing to draw a sphere, so assume this is a sphere, and it has an radius r, so it is also we can represent radius by small letter r. Now let's go to the second step of the problem. In this second step, we have to identify the variables and assign the symbols to those variables. So let me just move it a little bit up. So the variables, as you know, that we are talking about the volume of a sphere, and we can see that one variable is radius r, and and it is given that radius is 6 centimeters, so I'm going to take r as 6 centimeters. Also, it is given to us that uh, its radius is increasing. Increasing is a very important word in this case. So rate of change of radius, which is dr over dt with respect to time, is given 1 centimeter per second. Okay. Now also in this question, we have to find the rate at which the volume of the balloon is increasing. What that means is we have to find the value of dy over dt for sure. Okay, so the reason why it took one positive because of the word increasing. Okay, if the radius is decreasing, then we would have taken -1 here. Okay, so now after we identify the variables and what we have to find, so let's go to the third step of our problem. In the step 3 of this problem, we have to write the equation that relates the variable. We know that the volume of a sphere is 4 over 3 pi r cube. So that is the relation, and if you don't know how to find this, I have attached a formula sheet. You can use it, and you can use this formula. But now let's go to the next step. After we know the formula, all we have to do is we have to differentiate both sides of the equation now. That is the step 4. So but we have to differentiate both sides of the equation with respect to time. So it's gonna be d over dt of 4 over 3 pi r cube. Now as you know, 4 over 3 pi, this is a constant. Okay, so we can write it as 4 over 3 pi as it is, and derivative of r cube. Now, so what is the derivative of r cube? Our derivative of r cube is 3r square, but don't forget to put then dr over dt, since we are differentiating with respect to time. Okay, now in this question we can clearly see that we have 1 3 in the numerator, 1 in the denominator. We can cancel them, and once you cancel and once you simplify, it's gonna be 4 times pi time r square. So this is the relation we have, 4 pi r square dr over dt. Okay, so that is the step 4. We did differentiate with respect to time. Now we have to do the one last step in this question, and in the last step all we have to do is we have to substitute the value. So again, let me rewrite the step 4, that we did dv over dt as 4 pi r square dr over dt. Keep in mind, we have to find the value of dv over dt, change in volume with respect to time. So it's going to be 4 pi, and radius of this problem in the beginning, it was given to us. You can see we already wrote that in step 2, that radius is 6 centimeters and dr over dt is 1. So all I'm going to do is I'm going to go up and I'm going to replace radius with 6 and dr over dt with 1. So in this case, so what is the rate of change of volume with respect to time t? We have to just multiply 36 times 4, 144 pi, and then units are very important, so units will be cubic centimeter per second. So that is the change in volume in this case. So this is how you will solve this problem. Hope you understand this problem well. Thank you.